Hey there, ladies and gentlemen, boys and girls. Today I'm going to go through a couple of the practice problems, not all of them, but I'm going to pick three, one of the easy ones, medium and hard ones that highlight the uses of and the procedure of the Hardy-Weinberg equilibrium in using those two different equations. The P plus Q equals 1, which is for allele frequency, and then P squared plus 2PQ plus Q squared equals 1 for genotype frequency. Since we're diploid, we need 2 of each one. That's why we get P squared, and so on and so forth. All right, so first one I'm going to do is number 4 here, because it does a lot of different things. All right, we're going to do it. We're going to talk about it. Hagrid here. Hagrid is breeding dragons for his Care of Magical or Mythical Creatures class next semester. The winged dragons, the winged trait in dragons is dominant. What is the frequency of heterozygote dragons in the population? So first thing you have to do, there's 21 dragons below. You have to figure out what percentage of them are dominant and which one of them are recessive. All right. So first things first, if you look at it, out of the 21, out of the winged dragons, 14 of them are winged. Let's get that a little bit thinner there. And 7 out of the 21, or 33%, or 0.33, are going to be recessive. All right. And so that right there, to know that they are, since the dominant allele, or it's dominant, we know that these ones that are non-winged have to be little w, which we also know is Q squared. So we already, just by doing the first step and counting them, we've already figured out the first part. We know that Q squared is equal to 0.33, right? So that was done nice and easy. All right, next step is what we're going to need to do is we are going to need to find, I would say, this is the one equation, P plus Q. Oh, you can't write off the page, sorry. P plus Q equals 1. So if we can get P or Q, the rest of this is pretty straightforward. So to find, if we have Q squared is equal to 33, to find Q, I would need to take the square root of both sides. So the square root of 0.33 is 0.57. I just plugged in into my calculator. Square root of 0.33 is 0.57. Now, this is going to differ, or these answers are going to be slightly different when you calculate based on where you're rounding. All right, so that means P plus Q equals 1. If Q is 0.7 or 0.57, then we know that P must be 0.43, because that has to equal 1. These two need to equal 1. All right. So then we can just find out the rest of them. So if 0.43 is PQ, or Q squared, which is homozygous dominant, right, which is be 0.43 squared, which is, again, the numbers are going to be slightly different depending when you round. All right, it's going to be 0.18. It might be 0.19 depending when you round, or 18%. And then heterozygous, it would then just be 2 times 0.43, which is P, times 0.57, which is Q, and you're going to get heterozygous is going to be 49 or 49%. All right, of the dragons are likely to be heterozygous. So you're just going to have to solve for one of them and figure out the rest. The most important thing about doing these ones is just figuring out what do you know. With what you know, can you get P or Q? Because once you have P and Q, the genotypes are all really straightforward. All right, so let's look at another example here. Let's do, which one do I want to do? Let's do this one here. All right, let's do number 7. The allele for unattached earlobes is dominant over the allele latched, or for the is dominant over it. So this is going to be dominant, which is going to be P. And that's going to over on or attached alleles, which is going to be Q. In a population of 500 individuals, 25% of the population show the recessive phenotype. Right? So to be recessive, they would have to be the two recessive alleles, or what we just figured out there is 25% of them. What we just figured out there is Q squared is 25%. How many individuals would you expect out of the 500? How many individuals would you expect to be homozygous dominant and heterozygous? Okay, so let's start with what we know. All right, if we know Q squared is 0.25, I want to get to P and Q to be able to find the homozygous dominant being P squared and heterozygous being 2PQ. All right, so I would just have to take the square root of 0.25, which is Q is equal to 0.5. Well, that makes that easy. P plus Q equals 1. Q is 0.5, which means P is also 0.5, which means P squared is 0.5 squared, or 0.25, because I would just take that P and square both sides, right? And 2PQ, or heterozygous, would be 0.5. That would be 2 times 0.5 times 0.5 is 2. Sorry. Or is 0.5. Sorry. But now I want to know how many individuals in that. So out of 500 people, 25% are going to be recessive. 25 are going to be recessive. 25% are homozygous dominant, and 50% is heterozygous. So that would mean out of the 200, 50% of them, or 250 people, are going to be heterozygous. And out of 500, a quarter, or 0.25 of 500, is 125 people are going to be that. All right, so that one's a little bit multiple steps here. All right, let's try this one here. Number 10, last one. In peas, a gene control flower such as that the dominant is purple and the recessive is white. In an isolated pea patch, there are 36 purple flowers and 64 white flowers. All right. How many purple flowers are homozygous dominant? So we know out of these 36 purple flowers, that could be homozygous dominant, or it could be heterozygous, because it just means it could be either, big R, or big R, little r. So we're trying to figure out which one, or how many of them are just this right here. So let's think about what we need to figure out. Well, to figure that out, I need to know what P squared is. That's what I'm trying to solve. What I do know is 64 out of the total 100 flowers, 36 plus 64 is 100. Out of the total 100 flowers, 64 of them are white, which is the little r, or little r is 64 out of 100, or 0.64. Little r, that is our Q squared value. So I know in these examples here, I've done use Q squared. It's just there's only P and Q, so it's one or the other that you're trying to solve for. So then I just go through the whole process again. If I can find P or Q, I can find P, and if I have P and Q, then I can find P squared or any other ones I want. All right, so square root of 0.64. Starting to see how this is getting kind of methodical here. all right, is 0.8, which means in that case, P must be equal to 0.2. But I want to know P squared, so I just take 0.2 times 0.2 or 2, or right? So I would want P squared is going to be the 0.2 squared, which is 0.04 or 4%. Well, 4% out of 100 are 4 of those flowers are going to be big R, homozygous dominant. All right, so I hope that helped a little bit there. It's a lot of the math. I can't stress enough. Couple things. Start with what you know and think about what you're trying to find. And then find P or Q, whatever you're given, try and get to either just P or Q. If you're given P squared, get down to P, because then you can find P and Q, and you can find the dominant recessive alleles in from there. Otherwise, it's a thinker. Check your answers on the key, and good luck, everyone. Hardy-Weinberg's a tricky one. Just take your time and do the best you can. Good luck, and may the science be with you.